Okay, today we are looking at the assignment questions. And we're looking at assignment 1 for characteristics of quadratic functions. So far, we've looked at quadratic function, describing its characteristics such as its shape, its vertex, leading coefficient, end behavior, y-intercept, and x-intercept along the range and domain. The first set of first set of questions we looked at when you were given a graph to describe it, the quadratic function. In the next lesson, we looked at when you were given just the equation but no graph. So today, I'll be going through a few examples, a few assignment questions. We're looking at assignment 1. So today is all about assignment 1 question. So I looked at the first one, the second question, and I'll look at the next set of questions would be questions in your booklet here. Find this. We'll be looking at 3, and I want to look at some other rather interesting ones when you're not given question 6. So we'll go through some other ones we didn't do any example of, so try and complete ones where you're not given the y equal to, seems to be y plus, and I'll show you how to do it. So let's start with the first question, and by the way, you'll need your graphing calculator and or Desmos, either one. It's here. So assignment 1, and here you're given the graph, and you're asked to provide the requested characteristics. Now this graph is going upwards, so we can write it up here. It's going upwards. Now, if any graph is going up, the leading sign of a leading coefficient is positive. Okay, this y is equal to ax squared plus bx plus c. So it's a positive. The a is positive. The end behavior is from quadrant 2 to quadrant 1. So we say quadrant 2 to quadrant 1. Now the y-intercept, now better look at this very carefully here. Right down here is -3. So -3. Now there are 2 x-intercepts, which would be -1 and 3. So it's right here is -1 and this is 3. By the way, do not write it in this form. This is giving me my coordinate point. So don't write it with a bracket and a comma in between. You're going to write -1 and 3. So there are 2 intercepts. If you want to write it in bracket, this would be -1, 0, and 3, 0. So in the past, I've seen students written it like this: -1 and 3, and that's the point, -1, 3, which would be down here. That's not what you want. No. X across that. The vertex. Okay, now the vertex now would be this point here, which is 1, -4. So you have 1, -4. That you have to write it in a bracket with a comma separating it. The minimum value is your y value for your vertex, which is -4. There's no maximum because the graph goes to infinity. So there's none. Now the domain is all the real numbers, or you can write it as this guy here. All the real. The range now is from -4 going up, including -4. So pretty straightforward in the sense the graph is given. Now, what happens when you're given the equation? I'll do one example here. So here you need to go to your calculator, clear my calculator from my previous examples. I'll leave y equals 0 here because I need to find my y-axis, my x-intercept. So first thing you want to do, you want to enter this into your calculator. So I'll zoom out so you can see full view of the calculator. I'll move this down, so I'm gonna, oops. First thing, enter into your calculator, and we can determine, we can tell from the equation that this graph is going up because the a value is positive here. But we let our graph and calculator show us. So we'll enter this first. We have 3x squared plus 10x minus 13 in graph. And notice, you only see part of the graph. You don't see the minimum. This graph is going upwards, so we can see right now it's going up. But I want to see my vertex way down at the bottom. So I'm going to go to my window because notice it's restricted here to -10. So I want to go below -10 on the y minimum. So I'll go change that. Y minimum is flashing there. I'll put maybe -50 just to see. I'm doing an estimate here, right? Oh, I went a little too far, but that's fine because now I can see my x-intercepts and my vertex. So the sign of a leading coefficient is positive. The end behavior is from quadrant 2 to quadrant 1. Right? This graph is going to infinity at quadrant 2 and going to infinity in quadrant 1. So we say this quadrant 2 to quadrant 1. The y-intercept now for your graphing calculator, remember your function y-intercept trace. Oops. Press enter. X equals 0, y is -13. So we put -13 there. The x-intercept now are these two here. So we're somewhere in between what? -1, 2, 3. Just below -4 and slightly above x1. So let's go ahead and do that. Go to your y equal button. Make sure you have y2 equals 0. Then second trace. Go to intersect. I'll go to my left first. Doesn't matter which. And press enter 3 times. So that gives me a value of -4.33. So I'll put here -4.33. And I need to find the one on the right side. Second trace. Intersect. Press my right arrow key, go to my right. It's close to the x-intercept and press enter 3 times. Oops. Did I press it more than, okay, it tells me 1, but let's try that again. I think I did. There it is, okay, x equal 1 and 1. The vertex now, this is the one we need to, I need to show you that. And this is where you will want to use your here we want to find the vertex. Right, so this is the vertex. The first step, now we want to find the point, the turning point, the minimum in this case here, right? Make sure we have our equation here. And the next step, we press second trace. And because this graph is going up, we want to find the minimum value. So it's going up. It doesn't go lower than the minimum here, which is the vertex, which you need to find the vertex. So second trace. And when you go to this menu, you see value 0, minimum, maximum. We want to say to the minimum in this case. If it's going down, we'll choose maximum. So we'll go down to minimum. And it says left bound. Now, by the way, all of this is in your booklet. If you go on page 6. Okay, we did this in lesson 2. So go back to page 6 and you have it in all visual form. If you are still not too sure. It's also on this as a shortcut. So now I need to find my vertex. I'm going to continue. So it says left bound. Now move to my left of the vertex. So the left, press your left arrow key, make sure your cursor to the left, slightly above left. Then you press enter. You see a line. Now there's an arrow pointing to the right. So go to the right of the vertex. This was telling you. Press enter. And press enter one more time and you have your vertex. So that's your vertex. Your vertex is negative 1.7 approximately. Or 1.67 and 21.3. So that's your vertex. So your vertex bracket is negative 1.67 and negative 21.33. The minimum value now is the y value of the vertex. The minimum value is negative 21.33. There's no maximum. The domain would be all of the real numbers, negative infinity to infinity. The range now is from your minimum, which is negative 21.33, to infinity. And it includes to infinity. So we'll do a sketch of that graph right now. We'll say it's going with negative 4 here. And 1. And our y-intercept is negative 13. So we know our graph is square. So axis symmetry, it's over. So be careful with these graphs. Now, I'll go through a couple more. Now, with Desmos, okay, let's go to Desmos here. Let me go back. Clear. With Desmos, it's similar, except now with integral equation with 3x. Oops, no. I put my y equals. This is the difference between Desmos and your graphing calculator. You have to enter the y. And I'll show you how easy it is with Desmos compared to the graphing calculator when it comes to functions when it's not only y equal to. Okay, let's first of all, let's center my okay, let's go ahead and so y equal to 3x squared. so we have y equals 3. You have x, and this is your square button. And plus 10x minus 13. And press that and There's a chevron down so you can see a graph. Now, you can see it's going up. It's positive quadrant 2 to 1. The y-intercept, you tap where it intercepts the y-axis, negative 13. Your vertex tap is negative 1.67, negative 21.33. Your x-intercepts roll there. So with your Desmos, it's quite straightforward. It's just by tapping to find your intercepts and vertex. Graphing calculator, you have to follow a series of instructions for that. Now let's go on to the question 3. Assignment 3 question. Now, direction, notice is negative. So we expect this graph to be going down. But let's use our graphing calculator. Okay, I'm going to go to click that button there. And I'll enter exactly what I have there. So negative. Okay, I'm going to show you keypad. So I'll do it over here. Actually, might be better off being it here. Okay, there's a lighting. And make sure you. Okay, press your negative button down here, negative 0.5 or 0.5, you say negative 0.5, open bracket, x minus 1, close bracket. And this is where you need to indicate your square. So you can press this button here, automatically goes to the power 2 plus 7. That's all you have to do. Then press graph. Now this is my previous question. So notice it's well set up. But if I didn't set it up initially, you will see a different shape. Sorry, a different view of it. Now this is negative, so it's opening downwards. So we got down. Center leading coefficient being negative. End behavior in quadrant 3. So we navigate from quadrant 3 to quadrant 4. Now, the y-intercept, we have to press your second, trace, enter, 0, would be 6.5. The x-intercept, now we go back to my equation here, make sure y2 is equal to 0, the graph. Second trace, I need to find my intersect, and I'll go and let's find the right side first. So move my cursor to the right using my right arrow key, and press enter 3 times. So the first one is given as x 4.74. So 4.74, and we'll find the other one which is on the negative side. Second trace, intersect, move over to the left. Press enter 3 times, and it's negative 2.74. So here we have a y-intercept is 6.5, and we have 4.74. So let's do our scout. We need to find a vertex. So I'm jumping the gun here. Now to find the vertex, remember our steps. To find the vertex, you press your second trace in this. Oh, by the way, sorry about that. This is your maximum point. It's going up to the maximum. So I need to find my maximum here. Not a minimum. The previous question was on the minimum. So in the previous example, we had the minimum point here for the vertex. We're going to find our maximum. So second trace with a maximum. And see, left bound is already in my left side, but I just can move it a little bit. It doesn't matter. It's on the left side already of the vertex. If it's there, then you press enter. Then I would say right bound. You move to the right of the vertex. Stop. Press enter. And press enter one more time. And that will give you the vertex as 1, 7. So x is 1, y is 7. There's no minimum value because the graph is going down. The maximum value is your y coordinate point of your vertex, which is 7. Domain is negative infinity to infinity, and the range now is from negative infinity going up to 7. Oops. So I'll do my sketch now, so I can, so we know this is 1, 7 is here. This graph is going through here. Oops. Now, make it a little bit smoother. It's a little too far. Negative 2.74. And our vertex is 1, 7. Question 4 is similar to one we did earlier, so I'll skip that one. You can try. The answers are the back of the booklet. Now, the one I would like you to look at is this, a couple I would like to look at. And this, especially for your graphing calculated ones. It's a little bit tricky in the sense that you may not see your graph. So I go to my calculator here, and I'm going to enter a little bit here. Now enter this into my calculator, negative 12x squared plus 192x minus 543. Press graph, and the chances are you wouldn't see anything. I can see here no matter what I do. Oh, I do see something, but only part of it seems to be a line. Now, if this happens, to see the graph, you're going to press to view graph, press the zoom button, press the zoom button and the 0 button. Let's see what happens. Press my zoom button and 0. It'll take a few seconds, and there, what you're doing by pressing zoom 0, you are zooming in to the graph. Now notice I'm not seeing the right side. So, but look at my domain here, my x coordinate. It goes to positive 10. So I want to increase my, oops. Maybe let's give a better view. Okay. Seems to be the lighting is off. Okay. So here's my parabola. I know it's opening down, so we know that, but I want to see the other end of my parabola. So look at if I go to my window, my x maximum is up to 10, so I'm going to increase it. Maybe make it 100, see what happens. And there you can see more of the graph. I went way beyond, but that's fine. Now I can see my graph a little bit more. Now I can get a better view by restricting my domain, go back to window, and maybe make that to maybe 25, see what happens. You can see it's going down. Now notice I need to see my vertex a little bit more clearer. So it seems to be somewhere I'm not seeing enough. So this is my y maximum going up. This is y minimum. So go to my window and change my y maximum. It's at 224. The minimum is negative 3,000. So it's 663, which is huge. But I want to increase my y maximum, make that 300, maybe 400. So give me a. So that's sufficient because I can see my vertex. Now I can go ahead and describe the graph so we know it's opening down. Set the leading coefficient is negative. The end behavior is from quadrant 3 to quadrant 4. Now the y-intercept now, we have to go to second trace 0, x equals 0. The y-intercept is negative 543. So that's why it's way down here, right? So negative 543. So 543. You could have determined it, sorry, from here. The x-intercepts now. So second trace. Now, by the way, make sure you have y2 equals 0. Second trace intersect. I need to find the first one. It doesn't matter which one, so I move up to here. First curve. Press enter, enter, enter 3 times. This is the first intersecting point is 3.67. So 3.67. So we have here 0.67. And the other intercept, we'll do it again. Trace, intersect, move over to the right. Press enter 3 times, and it's 12.33. So let's it's not drawn to scale, obviously. So we're gonna move that. Now I need to find my vertex. It's the vertex now. We go second trace, and it's the maximum point. Enter. Say left bound. Make sure you go to your left. You have the following instruction. This is here. It doesn't have to be below the x-axis. You can leave it right to the left of the vertex. Press enter. Then go to the right of the vertex. Press enter. Press enter. And it's close to 8. We can say that's 8. So we said 8, 225. So this point here, the vortex is 8 to 25. The minimum value, there's none because the graph is going. The maximum value is 225. Domain is from negative infinity to infinity. And the range now is from negative infinity to 225. Now with Desmos, let's go back to Desmos. We can just get rid of, all these here. Now this happens. We have to turn it off, back on, back to Desmos. So negative 12 x squared plus 192. Okay. I'll zoom in a little bit more. X minus 5, 4, 3. I'm going to press the home button. Now notice my graph is very, very narrow. So you have to pinch it, and that's your vertex, 8 to 25. Then you go find your x-intercepts, 12.33 and 3.67. And this is where you may have to go down to a little bit here and find your way below here. So it's a little bit trickier when you have these huge values for intercepts. Now, I want to go to one more question, which we haven't done before, and it is question 6. Now, if you look at question 6, it doesn't look like what we've done before, but it is, because there's 3 on this left side. You cannot enter it into your calculator, your graphing calculator. You can do it in Desmos, but not in the graphing calculator. So you need to change this form to isolate the y, because you have y plus 3 here. To do that, we take the 3, we subtract 3 on the left side, and we do exactly that on the other side. So in this case, what we have here, we have y plus 3 equals 5x. So just give me some space here. Y plus 3 equals 5x plus x squared. Now I'll take away the 3 on the left side. I must do exactly that on the other side. So 3 minus 3 is 0, so we have it y is equal to 5x plus x squared minus 3. Now, if you're not happy to see the x squared in the middle here, you can change it around. You can say it's equal to y is x squared plus 5x minus 3. So I'm changing this form, y plus 3, to isolate the y, so on a y, because you can only enter this in this form in your graphing calculator. It will not work y plus x. Once you have that, you can realize the direction is going up, leading coefficient is positive. The end behavior we know is from quadrant 2 to quadrant 1. The y-intercept, you can tell here, is -3. X-intercept you don't know, the vertex you don't know. Now, since it's going up, we know there is no maximum value. And this domain is from -infinity to infinity. The range now, we need to find a vertex for that, and that will give us our minimum value. So let's go ahead into that integral calculator. And I'll show you in Desmos, it doesn't really matter how it's done. So I'm gonna reset my calculator. I'm gonna go to Zoom here, and I'm gonna go to standard. So now I'm gonna change. Okay, I should have first of all deleted that equation. Now I'm going to enter this equation. Notice you couldn't have entered this equation into your graphing calculator. So it's changed in that form. So now here's my new form. It would be x squared plus 5x minus 3. Okay, so now we graph. And notice, here it is. We know it's up, it's positive, quadrant 2 to quadrant 1. Y-intercept is -3. So I'm going to go second trace to verify it. X equals 0, y is -3. Now I need to find my vertex, second trace, go to my minimum. Let's say go to the left of the vertex, press enter, go to the right of the vertex, press enter, and press enter one more time, and that will give me -2.5. -9.25. So the minimum value is -9.25. We need to find our x-intercept. We go to second. Oh, by the way, make sure we got a y equals 0 and y2 is y equals 0. Second trace, find my intersects, and I'm going to find my, since on my left side, go to the, press enter 3 times. So that gives me -5.54. And there's one on the right side, second trace, intersect, press enter 3 times, that is 0.54. So here we have my -5.54, 0.54, vertex, well, first of all, y-intercept is -3 here, and vertex is -2, 1.5, so here. So this would be my sketch. Now the range is your minimum value here, which is 2.25, -9.25. So -9.25, including it to infinity. So those are, this is the one we haven't done before. The other ones, the y is at the end here, it's the same as, you can put a y in the front here, it doesn't make any difference. But I just want to go over with Desmos for this one here. So press my chevron on, I'm going to change that. Now, let's try with Desmos, see what happens, right? You put y plus 3 equals 5x plus x squared. Okay, and then we'll press the home button, and there's our graph. So with Desmos, you do not have to change its form, but the graphing calculator you do. It's just that the way it's designed, unfortunately. So we can tap, 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 and they are all over vertex. So here we have 2.25, negative 2.25, 9.25, our intercept is R 0.54 and negative 5.54, and our, oops, I didn't, here should be here through there, negative 3. So should be somewhere here, negative 3. And 0, negative 3 is our x or y-intercept. By now, you should be able to complete the hand-in assignment 1. That is due on Friday. You may also want to practice these 2 questions. Just for practice, to give you enough practice. And the answers are at the back of the booklet. Our next lesson, we'll be looking at application of quadratic function. How this is used in real life. Okay.